At Overair, we want to change how people live their lives by providing a mode of transportation that allows them to do things they could never do before. At Overair, we're creating a best-in-class electric vertical lift aircraft to get people safely, easily, and affordably where they need to go. The attributes necessary for success in urban aerial transportation are vehicles are going to have to be, of course, extremely safe. They're going to have to be very, very quiet, and they're going to have to be very, very energy efficient. And the all-electric vertical lift propulsion that we've developed is an exact match for those attributes. Our propulsion technology gives us a big advantage in payload carrying capacity. We're able to carry 5 people with their cargo, with their luggage, where they need to go. The propellers on our aircraft are larger than anyone else in the industry, and when you're able to move more air, you're able to generate thrust much more efficiently. That efficiency allows us to operate in a much broader array of weather conditions than other vehicles can operate, and that allows us to get you there much more reliably. Our facility here in Santa Ana has 200,000 square feet of floor space to support the scale of manufacturing operation that we need for early stage low rate production. Through the last several decades of development of vertical lift propulsion, we have developed a number of highly advanced composite manufacturing techniques that are necessary for this type of aircraft. And we've brought that rich history to the development of this facility and all of the equipment and capabilities that we have in our current composite shop. Our composite manufacturing capability is highly integrated with our engineering design team. So parts are designed on our CATIA CAD system and then immediately transferred to the automatic cutting machine to cut out the carbon plies, and then those are transferred to the molds using laser placement techniques to get absolutely repeatable structures produced over and over again, and then into the autoclave, and then the parts come out and they're trimmed and assembled. We work with the best external machine shops in the aerospace industry, but we also need to have our own internal capability that is capable of holding the exacting standards and also meeting very rapid turnaround times necessary for effective prototyping. We use the industry's best dynamics analysis and control law design software aimed at the kind of very complex vertical lift aircraft that we have. This is something that's extremely challenging even for today's computers to analyze, and using the right combination of tools and knowing how to interpret the results is really key to success here. In the 2 years that we've been operating, in addition to building up the facility and great team that we have, we've been focused on 3 main priorities. Number 1, working with the FAA to make sure that we fully understand the requirements that our vehicle will be held to for certification. Number 2, developing the design of the aircraft to those standards. And number 3, testing our propulsion system using a full-scale mobile test bed that is able to put the propulsion system through its paces. To be able to get the kind of data that we are seeking, there really is no other way than putting a real copy of the propulsor on a mobile platform and running it out in the desert at flight speeds. Developing a product like this requires some of the sharpest minds in aerospace, and it requires a diversity of view that comes from many, many different backgrounds. And we are successfully bringing people in from industries across the space that bring different vantage points on what makes really great transportation. All this technology that we bring together is ultimately in support of the big, bold vision of improving the way people live their lives in urban areas. We want to be able to provide transportation that gets people where they need to go to live the lives that they want to live.